Okay, here we go. Composition of blood plasma. So we're going to define colloid osmotic pressure, identify the various types of plasma proteins and explain the general functions of each, and list the dissolved substances in plasma by category. So starting off with plasma, it's composed of 92% water, 7% plasma proteins, and 1% dissolved molecules and ions. So it's an extracellular fluid, right? So it's going to be outside the cells, and it's similar composition to interstitial fluid, but plasma has a higher protein concentration than the fluid that we find in the interstitial spaces of tissue. Blood is considered a colloid, which just means that the plasma contains dispersed proteins. And there are a variety of plasma proteins. There's albumin, globulins, fibrinogen, and other clotting proteins, enzymes, and some hormones. And most of these are produced in the liver. So others are going to be produced by leukocytes or other organs, such as maybe like the spleen or your lymph glands. Plasma proteins exert colloid osmotic pressure, so this prevents loss of fluid from blood as it moves through the capillaries, and it helps maintain blood volume and blood pressure. It can be decreased with diseases resulting in fluid loss from blood and tissue swelling. For example, liver diseases that decrease production of plasma proteins, and also kidney diseases that increase elimination of plasma proteins. So if you have too few of those plasma proteins, it's going to have a negative effect on the osmotic pressure. It's going to go down. So some plasma proteins that we have. Our first one is albumins. They're the smallest and most abundant group of plasma proteins, about 58%, and they exert the greatest colloid osmotic pressure. And they act as transport proteins for some of our lipids, hormones, and ions. Globulins are our second group, and they're about 37% of the plasma proteins. They're smaller alpha globulins and then larger beta globulins. They transport some water-insoluble molecules, hormones, metals, and ions. And then we have our gamma globulins, or immunoglobulins, or antibodies, which we're used to hearing about, which are part of our body's defenses. Then we have fibrinogen, which makes up only 4% of plasma proteins, so a pretty small amount, and contributes to blood clot formation. So if you go ahead and have some sort of trauma, it's going to be converted to an insoluble fibrin strand so that it can go ahead and cover up those holes that may be coming through your skin, right? Serum is plasma with clotting proteins removed. So just think about if you didn't have fibrinogen, then you would have serum. And then we have our regulatory proteins, which make up less than 1% of the total proteins, and those are included in enzymes and hormones that we've talked about before. All right, so some other solutes that we find in blood, because blood is also considered a solution. It's got a lot of different solutes in it, like our proteins that we just talked about. And then we also have things like dissolved organic and inorganic molecules and ions. It's going to include our electrolytes, so think sodium and potassium and calcium and magnesium and all those things that we've seen when we're talking about our body's communication systems, and also, of course, nutrients like glucose, gases like carbon dioxide and oxygen, and waste products. These are going to be polar or charged substances that can dissolve really easily within the blood plasma, and then non-polar molecules are going to have some sort of carrier protein. All right, so what did we learn? Would a malnourished person eating inadequate amounts of protein have blood with high or low colloid osmotic pressure? So they're going to have too few of those proteins in their blood plasma, and so they would have a low colloid osmotic pressure. And then what functions do those albumins serve? They help keep up our intravascular colloid osmotic pressure. They're also going to help with neutralizing toxins and transporting different agents in the body.